Hello and welcome to this presentation of our paper. The paper is titled Comparative Assessment of the Completeness of CDISC Control Terminology. My name is Anas Al-Ghafari. I'm presenting this on behalf of myself and my co-author, Dr. Joseph Finkelstein. This was work that was done at the Icahn School of Medicine at Mount Sinai. So to start off by giving a bit of background of what we're talking about and why this is important. CDISC is the Clinical Data Interchange Standards Consortium. I think most of this audience will be aware of what CDISC is and its importance, but just to give a bit of a quick overview, this is a suite of standards that includes C- for data collection, SDTM for clinical trial data and representation of that data, SEND for preclinical studies, animal studies, etc. The foundation of the standards, at the foundation lies the control terminology. And this defines the code lists, the variable names, the values that may be used in CDISC compliant data sets. So the control terminology specifies what are the variable names for each possible variable, whether they are like demographics or outcomes, and which values may appear. And this control terminology is developed in collaboration between CDISC and the National Cancer Institute's Enterprise Vocabulary Services. Now, this terminology, the goal of it, or the function of it, is to harmonize the data representation across studies. So you might get several CDISC represented studies, and since they're using this control terminology, they will be representing the same data elements in the exact same way with the exact same variables. So, obviously this would be a desirable thing to have for clinical trial data. The unique importance of the CDISC standards partly comes from the fact that it is enshrined in regulation. So the SDTM, the Study Data Tabulation Model, is the recommended standard for FDA submissions. It has been this way since 2004. It's also since then has become the recommended or required standard for Japan's PMDA, which is Japan's equivalent of the FDA. Despite this unparalleled importance, there has been very little critical examination in the clinical trial data literature of this standard and of its limitations. In our survey through the literature, we've only been able to find 3 studies that looked critically at the CDISC standards and their limitations or their potential gaps when applied to real-world data or situations. So this is basically the goal of this work. What we have attempted to do is to examine the completeness of the CDISC terminology in relation to outcomes and endpoints of multiple sclerosis studies. Why multiple sclerosis? Well, it's an important condition, and it's been the subject of thousands of clinical trials. This means that we have a lot of real-world data about what multiple sclerosis trials typically measure, what are the typical outcomes and endpoints. And also there's also kind of a well-developed body of curated outcomes and data elements. This has been developed by the NINDS's catalog of data elements, which is openly and freely available on the NINDS's website. So, beyond examining this completeness of the terminology, we have also in our paper, we shared the results. Basically, we tried to highlight the relevant outcome measures that we found that were missing from the current control terminology. So moving on, the methods that we have employed We have used two independent benchmarks. One is like a real-world practice-driven benchmark, and this consists of 66 most common outcomes used in MS studies that were registered on clinicaltrials.gov. These outcomes were extracted automatically using an automated clinical trials pipeline. We have presented that work or explained it in more detail in a different article, which is mentioned here, listed here. And that pipeline essentially interfaces with clinicaltrials.gov, fetches all the relevant clinical trials for a particular condition, and then aggregates and extracts the most frequent outcomes and endpoints. In addition to this benchmark, we've also used an expert curated benchmark, and this consisted of 71 outcomes for multiple sclerosis that were developed by the NINDS's Catalog of Common Data Elements project. Okay, so these are the two benchmarks we are going to measure the CDISC completeness against. Now, the way we're going to measure this is the search and mapping pipeline. So CDISC, the terminology is available in a couple of different formats. The canonical form, the one that's kind of CDISC will say is the authoritative way to access the data is through the API. And I think they do it this way because they want to facilitate building applications and automated software that uses the CDISC terminology. So there's an API access that we use to fetch the data in JSON format. Basically, the way this is done is we submit a request, we get the data in JSON format. It requires some parsing. JSON, as to people who are not familiar, is somewhat similar to XML. It's basically provides a standardized annotation of the names of the code lists, the synonyms, the possible values, etc. We use the SDTM terminology, the CDASH terminology, and the QRS and QSFT terminology. But the SDTM really is the main one, and I think the QRS and QS is being folded into the SDTM, as I've noticed kind of anecdotally in the most recent releases. So after the JSON parsing is done, what we get from the parsing process, we get the variable names, synonyms, code lists, term names, term definitions, all of that. We build a search index, an inverted search index into all of this. This allows us to cast a very wide net when searching. And so when we have an outcome that we would like to map to its CDISC equivalent, we do a fuzzy search against all of these, name, terms, synonyms, definitions, all of that. We do a fuzzy search and we rank the results using Jacquard distance, which is basically a measure. It's kind of a string distance measure. The whole goal in the process is to not be a strict search and mapping, but rather to cast a broad, a wide net, and then to rank the candidate matches so that there's a post-processing step where the best candidate is selected from among the top 5 or the top 10. So that's the role of the manual verification, which is the third part in our kind of approach. So we have the benchmarks, the mapping of the benchmarks to the CDISC terminology, and then manual verification of the results. So the manual verification consists of, for those terms where we have found an equivalent, we go and verify that this actually, what was identified by the pipeline is actually the equivalent to the input term or to the input outcome. We, in the cases where the pipeline did not find any good matches, we also verify that actually CDISC terminology indeed does not have a match for this particular outcome. And now this gets a bit more difficult. This was more labor intensive. This basically involved looking at the CDISC terminology files, the spreadsheets that you can obtain from the website of the National Cancer Institute's Enterprise Vocabulary Services, and then going through them and manually checking each possible alternative, and to make sure that the outcomes that the pipeline said were not there, really were not there. This is the challenge of proving that something is truly absent, right? If you need to verify and double check that the absence is not some sort of a mistake somewhere in your processing. So we did this, and these are the results. So for the NINDS's outcomes, 71 outcomes. The ones that were covered in CDISC, included in the CDISC terminology, were 32. The ones that were missing were 39. So 55% of the NINDS's cataloged outcomes were not present in the CDISC terminology. For clinicaltrials.gov outcomes, our benchmark included 66 outcomes. 32 of them were covered in CDISC. 34 were missing from CDISC. If we look at the outcomes that were in both benchmarks, so what's the overlap between both benchmarks? There were 33 outcomes that appeared in both benchmarks. And of those, 21 were covered, so 64%. That's, fairly good, I guess. And 12 were missing. Overall, if we look at both outcomes, if we look at both benchmarks, we have 104 outcomes. The coverage for CDISC is 41%. So yeah, more or less, a bit less than half, basically, in most cases. Here are examples of some of the outcomes that were in either benchmark that were not in the CDISC terminology. The full list is in our paper, but if you look through this, you will see some pretty important stuff, things like multiple sclerosis spasticity scale. There's the Berg balance scale. There are various very well established intelligence and memory tests. Also a bunch of established surveys and instruments. So yeah, it's a long list. So what's the takeaway from all this? First, the absences. Many important outcomes are just not there in the CDISC terminology. Beyond just the individual outcomes, there were classes of measures that were missing. So there's no outcome for spasticity, right? So there were a couple of outcomes for spasticity in the NINDS's and the clinicaltrials.gov data that do not appear in the CDISC, and there's no alternative outcome for spasticity that is included in the CDISC terminology. Same for ataxia. This is important because if you have data from clinical trials that uses one of these outcomes, this data cannot be represented in a standardized format in the CDISC study. So you'd have to make up your own variable names and then extend one of the code lists. But if you have two different studies using this outcome measure, even though the outcome measure is well established, because there are no terms for it in the terminology, it cannot be represented in a standardized, comparable way between these studies. So that's basically the story here. That's the summary. We employed semi-automated session mapping to evaluate the completeness of the CDISC terminology. The input to this session mapping were two independent benchmarks, one from NINDS, one from clinicaltrials.gov. We verified the results manually. We found that more than half of the benchmark outcomes were missing from CDISC. This undermines the standardization power of the CDISC suite of standards. And I guess the takeaway here is that for the future, the development of the CDISC terminology would greatly benefit from considering the work and the efforts that were already made by other standards bodies, NI and the SB1 example. And also, it would also benefit from considering the real world practice in the form of the studies that are registered on clinicaltrials.gov. So that's all, and thank you for listening, and we will take some questions. Thank you.